Hello, welcome all to another US Study Buddy. In today's lecture series for 12th standard question bank, we are going to discuss about a topic that is differential equation part 2. In the previous video, we have discussed about the basics about the differential equation, how to find a degree and how to simplify, get the general solution and particular solution. Now, we are going to discuss about few techniques or methods that will be useful once you look at what is a form of a differential given to you. So let us understand few basic before we proceed. Homogeneous differential equation. When each term in the differential equation has the same degree or a constant degree throughout, it is said to be homogeneous differential equation. As you can see on the screen, example is given as x cube y plus xy cube plus x square y square dy by dx is equal to 0. It is the differential equation of degree 4. When we want to solve such type of differential equation, we make the substitution y is equal to vx and we replace dy by dx by v plus x into dv by dx. Linear differential equation. The differential equation of the type dy by dx plus py equal to q is said to be linear differential equation where p and q, these are the functions of x. To solve such type of equations, we first of all figure out the value of integrating factor, that is e raised to integration of p dx. And then the general solution is obtained by y into integration factor equal to integration of q into integration factor dx plus c. If you have the integration differential equation of the type dx by dy plus py equal to q, then general solution becomes x into if equal to integration of q into if dy plus c, and integrating factor is calculated by e raised to p dy. So let us now solve the first problem. So as you can observe in this differential equation, the degree of each term is 3 and it is constant throughout. So this is a homogeneous differential equation, and method to solve this is you put y is equal to vx and dy by dx is equal to v plus x dv by dx. So let us solve. So here let me rearrange the term. So I will be getting x square y dx is equal to x cube plus y cube into dy. So that means x square y upon x cube plus y cube. I am just transferring this term. So I will be getting dy by dx. And now I can make this substitution. So using 1, what I will be getting for dy by dx, I have to write v plus x into dv by dx is equal to, and wherever now there is a y, we have to replace it by v into x. So x will be as it is, but wherever there is a y, it should be v cube into x cube. That is what is the y cube. So what we observe, we have a common term of x cube in the numerator and denominator. So let me take it out common. So it is 1 plus v cube. So this is what we will be getting. Again, transferring this v on the other side, we get x dv by dx is equal to v upon 1 plus v cube minus v. I am transferring this on the right side. By taking LCM, we get 1 plus v cube. Now multiply by v, is it v minus v raised to 4. So x dv by dx will be equal to, so what you get? Here it is x dv by dx. It is equal to minus v raised to 4 upon 1 plus v cube. Now, by variable separable form, let me take this term here and x term here, because we always want dx and dy to be in the numerator. So, what I will be getting when I am taking this term, I have to take the reciprocal upon v raised to 4 into dv is equal to dx upon x. Right? And now we have to integrate both the side. So what we will be getting separately, if I just take this term, let me keep minus sign on the left hand side. Okay. So what I'll be getting is 1 upon v raised to 4, that is v raised to minus 4 dv plus v cube upon v raised to 4, that is 1 upon v dv is equal to minus dx upon x. Now these are simple formulas. X is to n. What is the integration of x is to n? It is v raised to minus 3 upon minus 3. 1 upon v is log of v is equal to minus log of x plus c. Now rearranging the term. Here what will be getting? Minus v. Let me multiply throughout by the negative 3. So what I will be getting is v raised to minus 3 minus 3 log v is equal to 3 log x plus c dash. Let me call it as c dash. Now, resubstitute the value. So let me gather all the terms on the left hand side and replace v. What is the value of v? From here we can get the value of v is equal to y by x. So let me substitute value here. So it will be reciprocal of y by x, that will be x cube upon y cube minus 3 log of v is again y by x is equal to log of x cube. I can just use the laws of logarithm and take it as. Finally, I can transfer this term here. I will be getting x cube upon y cube minus log of y upon x the whole cube minus log of x cube is equal to c dash. This is the final answer. Let us solve the next problem. Here, as you can see, the problem is find the solution for dy by dx plus y is equal to e raised to minus x. So, in this differential equation, what we observe, this is of the linear differential form. The standard form of linear is dy by dx plus py is equal to q, right? And when you are solving the linear differential equation, you have to calculate integrating factor if, and the formula is e integration p dx. And general solution is given by I into if is equal to integration of if into q dx plus c. So it is pretty easy. These kind of problems are very simple and easy to solve. So let us solve them. What is the value of p given to you when you compare? There is 1 into y, right? So p is 1 and q is e raised to minus x. So first thing is we need to calculate if, integrating factor. It is e raised to integration of p dx. So e raised to integration of 1 dx, and integration of 1 dx is x. So e raised to x is our if. Let us find therefore the general solution. It will become y into if. Let me rewrite the formula and then I will substitute the values. And it is if into q plus c, q dx plus c. So now what is if? Our if is e raised to x is equal to integrating factor is e raised to x. What is q? Q is e raised to minus x. So when you simplify this, you will get e raised to 0, that is 1, and integration of 1 dx will be x. So y e raised to x, x into x plus c, that is what is the solution for this linear differential equation. A right circular cone has height 9 cm and radius of the base is 5 cm. It is inverted and water is poured into it. If at any instance water level rises at the rate of pi by a centimeter per second, where a is the area of water surface at that instant, show that the vessel will be full in 75 seconds. So in this problem, we have been given a right circular cone which is inverted and we are pouring water into it. And we need to show that after 75 seconds, the vessel will be full. So when it reaches to its height, that is 9 centimeter, then it will be taking 75 seconds to completely fill the vessel. This is what we want to show. Let us see how to solve. So now let us solve this problem. As you can see, this problem is based on application of differential equation. And what is given in the problem? You have been given that you have a right circular cone, right? So this is what is a right circular cone, and its height and radius is given to you. and you have been given that water level is rising at the rate of pi by a. So as you can see, there is a water that is getting poured in this right circular cone, and we have to identify at what time this cone will be completely filled, right? So the maximum height, when we reach height from this 0 to this 9, then at that time the cone will be completely filled. Water will be completely filled in the vessel, right? So here what is given to you is water level rises. So rate of change of increase in the height when you are pouring the water, that is what is given, right? So this is what is nothing but it is rate of change in the level with respect to time. So dH by dt is given to you is pi by a. This is what is given. So this is what once we identify, then it becomes very easy to simplify the problem. Now what we have given their height and radius. If I just take their ratio, that is 9 by 5 implies R is equal to, so that is 9R is equal to 5H, and therefore R is equal to 5H upon 9. So that is what is the value of R that I take, and here we are talking about the right circular cone. So what is its base? Area of the base is equal to, it is circle, pi r square, right? So A is equal to pi r square. So what can I get the value of R in terms of this? Yes, I can. So what I can write here is, I can replace this A here. So this dH by dt will become pi upon pi r square. That is 1 upon r square. But I know the value of R from equation 1. And when I substitute that value, what I will be getting is 1 over, now what is the value of R? It is 5 upon 9 into h the whole square, right? So it is nothing but 81 upon 25 into 1 upon h square. Now we can easily solve this problem by the method of variable separable form, right? So what I can do? I can separate the variable h and t on the both the sides. So what I will be getting here is dH by dt. Once I have the value, I can have the h variable with dH. So h square. So it is h square dH is equal to 81 by 25 into dt. So now when you integrate both the sides, what you get is h cube upon 3 is equal to 81 upon 25. 1 dt will be t plus c, right? So this is what is the value that you will be getting after integration. Now what is the initial condition given to you? In a right circular cone, we have been given that height starts from 0 and height is 9, right? Total height is 9. So when water level will start from 0 level to the highest level, that is 9, when height becomes 9, the right circular vessel will be completely filled. So initially at time t equal to 0, the value of h is also 0, right? We are starting from here. There was no water and we started pouring it. So what becomes when I substitute this value in this equation, let me call it equation 3. So 3 becomes, we get c is equal to 0. So keeping this value now in this equation, we get h cube upon 3 is equal to 81 upon 25 into t. Now we need to figure out at what time the vessel will be completely filled. So when height reaches to 9, then the vessel will be completely filled, right? So when vessel or water reaches to h is equal to 9, vessel will be completely filled. So let me substitute in this equation 4 the value of h as 9 so that we can figure out at what time it will be completely filled. So in 4, if I substitute h is equal to 9, it will be h cube, that is 9 cube upon 3 is equal to 81 upon 25 into t. So let us calculate t. T becomes, it is 9 into 81 upon 3 into reciprocal of this is 25 upon 81. So t becomes 75. So that means after 75 seconds, the right circular vessel will be completely full. So this is how you can solve the problem on differential equation, and you can also attempt the problem based on the application of differential equation. So it is advisable that you remember the form of a differential equation. Once you identify the form, then you know the steps and method to solve. Like homogeneous, in homogeneous differential equation, you have to see through the differential equation if the degree of the each term is same, constant throughout, right? That is what is the trick. And secondly, in the linear differential equation, once you have identified the values of p and q, simple thing is you need to calculate the value of integrating factor, and then you can write the general solution. So I hope you are very much clear about how to simplify the problem using this topic, differential equation. So do solve the exercise given in the end of the video and write your answer in the comment box. If you find this video helpful, please like, comment and share, and also click on the bell icon. Now in the next video, we are going to discuss about the topic called probability distribution. So stay tuned. See you very soon. Thank you.